All right, this is Geometry A, Unit 4, Lesson 4. We're going to talk about reflections. Reflections. You've seen reflections when you look at a mirror. So you raise your right hand and your left hand and your image pops up. Things are reversed. You see it in a mountain being reflected in a lake. The mountain that appears upside down above the sky looks upside down in the lake. Things are reversed. The idea of a reflection is this. I'm going to perform what's called an x-axis reflection. And the x-axis, being right here, is a horizontal line, right? Corresponds to all y coordinates that are 0. And so we're going to reflect across this x-axis. I'm going to pretend this is maybe the surface of a lake or a sheet of glass. Okay. Note that A is 1 unit above, so A prime, its image, is going to be 1 unit below. C prime, which is 2 units above, is going to be 2 units below. And B prime, which is 2, 4, 6, 7 units above, is going to be 2, 4, 6, 7 units below. Okay? And as you can see, the triangle A prime, B prime, C prime is inverted. It's flipped upside down. Now, what's more important is I want to take a look at the coordinates of A prime, B prime, C prime, and I want to see if we can figure out what has happened to the coordinates. Okay, let's take a look at the coordinates. A prime, so A became A prime, which is at -2, -1. B prime, which was at 5, 7, is now at 5, 2, 4, 6, -7. C prime, which was at 6, 2, is now at 2, 4, 6, -2. Okay, so as you look at this, what has changed is the x values all stayed the same. The y values changed. The x values stayed the same, -2, -2. The y values changed signs. Okay, and so we're going to introduce something called transformation notation. You remember how we talked about you can describe a transformation using directions, a description. You can use equations. You can use with x1 and y1, x1 and x2, y1 and y2. You can use functions, and you can use vectors, right, for translations. I'm going to use this particular form here. It looks like this: x, y becomes x -y. Notice what changes. All the y values change signs. So for an x-axis reflection, change the signs on y. Okay, for an x-axis reflection, change the signs on y. All right, let's go ahead and do the same thing now for a y-axis reflection. Y-axis reflection. Okay, what we're going to do is we're going to treat the y-axis as a mirror to reflect across. So this is our mirror. And in a reflection, objects remain the same distance on either side of the line of reflection. So A is 2 units to the left, so A prime is 2 units to the right. B is 2, 4, 5 units to the right, so it's 2, 4, 5 units to the left. C is 2, 4, 6 units to the right, so C prime is 2, 4, 6 units to the left. Okay, And so here we go. Let's connect these, and we'll see that the triangle has been flipped horizontally. It's been flipped horizontally. Okay, but it's still the same triangle. Okay, let's look at the coordinates. A is at -2, 1. A prime is at 2, 1. B is at 5, 7. B prime is at -5, 7. C is at 6, 2. C prime is at -6, 2. So what has changed? The x's have all changed signs from negative to positive, positive to negative. The y's have all stayed the same. And so we, in transformation notation, xy has become -x, y. Okay? So that's a y-axis reflection. And notice what's changed. For a y-axis reflection, change the sign on the x's. For the x-axis reflection, change the sign on the y. It's kind of backwards when you think about it. Okay. All right. Next type of transformation is going to be a reflection across the line y equals x. Y equals x. To graph y equals x, graph a 0, 0. And then graph 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, and so on. And you'll notice you get this diagonal line. Diagonal line. Okay? And so we're going to reflect across the line y equals x. And let's see what happens here. Okay, let's line it up right there. And right there. Okay, so here's the line of reflection. Remember, this acts like a mirror, so every object is equal distance on the opposite side. Okay, so A is 1.5 diagonals away from the line, so 1.5 diagonals away puts us right here, A prime. B is 1 diagonal away, so 1 diagonal away here, B prime. C is 1 diagonal, 2 diagonals away, so 1 diagonal, 2 diagonals is C prime. Okay, and let's trace or draw the triangle that results. Yeah, when in doubt, graph it out. If you have any questions about how to do a transformation, try drawing the graph. It makes a lot more sense once you see a picture. And you can see, if you tilt your head slightly, that this has been flipped diagonally. Now let's look at the coordinates. A is at -2, 1. B, A prime is at 1, -2. 1, -2. B is at 5, 7. B prime is at 7, 5. C is at 6, 2. C prime is at 2, 6. Do you see what's happened? The x's and the y's have switched. They've switched places. So for the transformation notation for a reflection across the line y equals x is to switch the x and the y. Switch the x and the y. Okay? All right. And then there's another kind of reflection called a point reflection. Point reflection. So let's go ahead and look at that here. In a point reflection, or a reflection across the origin, it's also known as a double reflection. Every point goes across the origin, right? Across the origin. So A is two left and up 1. So the opposite side would be 2 right and down 1. Okay? This distance is directly opposite this distance, and they're the same. Okay? And B prime, or B, is 5 over and 7 up. So we want to go 5 left, 2, 4, 5, and 7 down. 2, 4, 6, 7. And again, you can see that they're directly opposite the origin and equal distance. So A prime, B prime. And C is 2, 4, 6, 2. So it's going to be the opposite direction, 2, 4, 6, 2. C prime. Okay. And this, by the way, is the same as if we had done an x-axis reflection followed by a y-axis reflection. But it's also the same as a reflection across the origin point. You can imagine the origin point as. It's also the same result you get by rotating 180 degrees. Okay? And so let's look at the coordinates. A is -2, 1. A prime is 2, -1. B is 5, 7. So B prime is -5, -7. -5, -7. C is 6, 2. C prime is -6, -2. Look at what's happened. XY has become -x, -y. The x's and the y's have both changed signs. So for a point reflection across the origin, we have a change in both signs. Change in both signs. Okay? That's why it's called a double reflection. It's the combination of the x-axis reflection and the y-axis reflection. Now, we don't have to reflect just across the x-axis, the y-axis, or the line y equals x. We can also reflect across the line y equals -x. We can also reflect across any line. So let me show you that. Okay? Let's reflect across the line y equals 4. Y equals 4. So we go up to 4. Actually, let's do -4. -2. -2. Y equals -2. Let's go to -2 on the y-axis and draw a horizontal line. That is the equation y equals -2, because every point on this line has -2 as its y coordinate. Okay? For example, this point is 0, -2. This point is 2, 4, 6, -2. This point is -2, -2. They all have -2 for the y coordinate. That's why it graphs as a horizontal line. Okay, and we're going to reflect across this line. And these ones really are best done by graphing. The lesson had you do some mathematics, but graphing is really the best way to do it. So we think, how far is A above the line? Y equals -2. It is 3 above, so A prime is going to be 3 below. A prime. B is 2, 4, 6, 8, 9 above, so it's B prime is going to be 2, 4, 6, 8, 9 below. And it's going to be off the screen a little bit. Just adjust here. So one more time. 2, 4, 6, 8, 9. B prime. And C is 4 above, and C prime is going to be 4 below. Okay? And we get the points, and we can draw the triangle. Draw the triangle. Here we go. Okay. Having trouble getting all the way down to B there. All right, there we go. And here, and I know this video is getting long. This is an involved lesson. Lots of material. Okay, here we go, right there. Okay, so we can reflect across a line that isn't the x-axis or the y-axis. In this case, A prime is -2, -5. And B prime is 2, 4, 6. No, 2, 4, 5. 2, 4, 6. Sorry, 2, 4, 6, 8, 10, 11. So 5, -11. And 6, 2 has become 6, 2, 4, 6. 6, -6. C prime, 6, -6. And there's some arithmetic you can do. Just basically it comes to that C prime is 4 above, or C is 4 above, so C prime is 4 below. So you think -2 minus 4 for the y coordinate is -6. And that's where we get that. Okay? That's really what it comes down to. All right. Hopefully that helps.